Okay, let's look at the first order linear equations. Right. So first order linear equation has this form. Y prime plus some function of x times y is equal to some function of x. Right. So in order to solve the first order linear equations, there's a very nice tool called integrating factor. So which is defined this way. Integrating factor I of x is defined to be e to the integral of p of x dx. Right? So what we do is we're going to multiply the entire equation by this integrating factor. So multiply by integrating factor. Right? Then you're going to have, so you have a y prime times e to the integral of p of x dx plus, right, I'm going to write y first, y times p of x times e to the, so this is the integrating factor. And the right hand side, I'm going to write it as q of x. And for this one, I'm going to just write it as I of x there. All right. And let's look at the left hand side. If you notice that this is actually the derivative of y times e to the integral of p of x dx. Alright, so this is just a product rule. You can see that the derivative of the first is y prime times the second, gives you that. And then first guy is y. Derivative of e to the integral of p of x dx would be p of x times e to the integral of p of x dx. Right? So this is exactly the result from the derivative of this using the product rule. Right? So this is equal to q of x times I of x. Right? So once you know the derivative, then we can take the antiderivative with respect to x. Then you will see that you're going to get the y times, so this is an integrating factor, so I'm going to write it as I of x is equal to integral of q of x times I of x dx. Alright, so by dividing through by integrating factor, we can have y equals 1 over I of x integral of q of x times I of x dx. Right? So we could find the solution of this first order linear equation. Alright, so let's do a concrete example. It's problem number 14. Equation is x times y prime minus 3y is equal to x cubed. Then there's the initial condition there. Alright, first thing we need to do is we need to actually divide it through by x so that the coefficient of y prime is going to be just 1. So this is going to be y prime minus 3 over xy is equal to x squared. Right? Then you can see that here, this guy is our p of x. And this right hand side, x squared, is our q of x. Right? So let's find the integrating factor. So I of x is going to be e to the integral of negative 3 over x dx. Right? Negative 3 is just a constant, put it in front. Antiderivative of 1 over x is natural log of x. Right? So this is going to be, you don't have to put the absolute value there. So this is going to be, so e to the natural log of x is going to be just x. Then you have negative 3 power, so you have to put that in there. Right? So the solution is going to be y is equal to, all right, 1 over integrating factor x to the negative 3, right? Integral of q is x squared times x to the negative 3 power dx, which is going to be, this guy is just x cubed, right? Then this is just going to be integral of 1 over x dx, right? Then evaluate that, and you will have x cubed times antiderivative of 1 over x is natural log of absolute value of x plus some constant c, right? So let's use this initial condition to find c. All right, y of 1 is equal to, so 1 cubed is 1, natural log of 1 is 1, so it's actually just going to be plus c, so plus c, and this is supposed to be 10, right? So c is 10, so therefore the solution y, particular solution, is going to be x cubed times quantity natural log of absolute value of x plus constant, in this case 10, right? So this is the particular solution of the initial value problem here, right? So we could use the integrating factor to find a solution, right? That's it. I hope that this was clear.